They have to be personnel carriers, toolboxes, and aerial platforms rolled into one. So, how do engineers create the ultimate tool for firefighting? Since 9/11, the fire department of the United States Capitol has been on high alert. The firefighters go about their daily job expecting the worst.
Being a DC firefighter, we can deal with just about anything from a sick person to a house fire, as far up to a major building fire to a terrorist attack here in the city. We can find ourselves in situations where we don't make it home, so we put a lot of emphasis on these fire engines to make sure that they work.
The fire engines they depend on are made here, in Clintonville, Wisconsin, the fire engine capital of the USA. Clintonville is home to Seagrave, the company responsible for building America's fire engines since 1881. The Seagrave fire engine has come a long way. It still has an engine, ladder, and pump, but those are the only similarities between these old engines and today's state-of-the-art machines.
Talk to the people that actually use our fire trucks, and the way they talk, this is the only truck built. There's nothing better.
So how does Seagrave build the ultimate fire engine so it's up to the toughest firefighting challenge? The first thing a fire engine needs is speed. But what sort of engine is capable of giving a hulking great 30-ton truck massive acceleration and a high top speed? The answer is this awe-inspiring 13-litre, 525-horsepower Caterpillar engine. The engine itself is almost as big as a car, and it needs to be. It has to haul over 30 tons at over 100 kilometers an hour, and what's more, it has to start first time, every time.
This is an industrial strength motor. It's not like you put in your normal pickups or nothing. This thing's made to take her and it's made to last.
Once the engine is finished, it's lowered into position on the axle, which is then wheeled away for the other components to be added. At the drill, the engine has done its job and delivered the firefighters promptly to the fire. Now it assumes a different role, to power the massive water pump on board. At each fire, explosions, crumbling buildings, and falling masonry add to the risks for firefighters. On 9/11, 36 firefighters are said to have been saved from death inside their cabs as the Twin Towers fell around them. So what's the secret of the cab's strength? The skeleton of the cab is a virtually indestructible frame of interlocking steel tubes. Its panels, though, are made of aluminium to reduce weight. The aluminium is cut on this $1 million laser machine that slices the frame to within a millionth of an inch.
This is the most advanced laser of its kind. We want to make the best cuts to make the best trucks.
The cab's steel tubes and aluminium panels are interlocked to create an incredibly robust subframe. The cabs are then lowered onto the chassis and on-board equipment installed. Fans, computers, storage. Back at the fire, the operation is underway, but the woman is still trapped. Lives depend on the ladders that each fire engine carries. These ladders are marvels of engineering in their own right. They've got to be light and long, extending to over 100 feet without causing the fire engine to topple over. But they've also got to be strong enough to cope with the weight of several people at a time, and even to be used as a battering ram, capable of smashing through walls or knocking in windows. Each ladder takes 5 weeks to build. The ladder starts off life as steel coil. Steel keeps its strength in high temperatures. Once the side panels are made, holes for the steel rungs are punched in. The rungs are strengthened with K-brackets, which allow each ladder to carry 230 kilograms at its tip. At the fire drill, the ladder is extended 3 stories up to rescue the woman from the burning tower block. Another life saved.
It's a real great job to have, knowing that you're building something that can save somebody's life someday. Firefighters have to be ready for action 24 hours a day, 7 days a week.
and so do their fire engines. Behind the ordinary is the extraordinary. The secrets behind tomato ketchup. Next on How Do They Do It? Ever wondered how they make tomato ketchup? It all starts at the annual Tomatina Festival. 15 tons of tomatoes arrive in trucks, and the entire population of this small Spanish town have the most almighty tomato fight. Then all they do is scoop the stuff up, add a pinch of salt, and shove it into bottles. Yeah, right. Every year, we consume more than 150 million litres of tomato ketchup. And although there are over 50 delicious kinds of ketchup, there's a 50% chance that your favourite brand is Heinz. They began producing the magic red gloopy sauce in 1876. In short, they've had 130 years to perfect the stuff. So, how do they do it? The ancient Roman town of Elst in the Netherlands. 95% of all the Heinz ketchup sold in Europe comes from this sleepy little town. And it all starts with one of these foil bags. Each bag contains 1,200 kilograms of tomato paste. But how do they turn plain crushed tomatoes into tomato ketchup? Remarkably, most people who work for Heinz haven't the slightest idea.
There's only 8 people in the world that know the recipe, and even I don't know the recipe.
Well, we can now reveal that the tomato paste is squeezed into large vats and mixed with vinegar, sugar and salt. Next, a man in white overalls with a hairnet picks up a blue plastic bag containing something and shakes whatever's inside into the vat. Then some men and women in white coats with no hairnets check that the contents of the blue plastic bags have had the desired effect. At 9 o'clock every morning, a sample from each batch produced the previous day is tasted by the Heinz taste specialists.
When you come in first thing in the morning and you taste ketchup before you have a cup of coffee, then people think it's very, very strange, but we're used to it.
But humans are weak. What happens if one of these ketchup connoisseurs is having an off day? At Heinz, there's no room for human error. So each batch of ketchup is also sent to the labs to test its chemical composition for acidity and saltiness. If a batch doesn't pass muster, it's rejected and binned. But there's one more bridge the ketchup must cross. In these health and safety conscious times, it was almost inevitable. Heinz has imposed a speed limit on its ketchup.
In 10 seconds, we can only have 10 centimeters flow of ketchup. That's the 10 centimeter rule. Well, this machine is what we call the quantifier, and it measures the thickness of the ketchup.
The velocity of ketchup is a huge worry. There's an ever-present danger that some unsuspecting customer will smack his sauce bottle too enthusiastically, inadvertently firing a dangerous dollop across the kitchen table.
Okay, here we go.
The arm is set at an angle to mimic the action of ketchup being poured from a bottle. And the Heinz scientists time the distance it takes to travel.
And it's perfect.
But what about the contents of those mysterious blue bags? Are the Heinz scientists among the 8 people alive who know the secret?
Yes, we know.
What's in the special recipe?
We can't tell you. It's a Heinz secret, I'm afraid.
It must be
Yes.
kept secret.
Finally, the ketchup is ready to go into the bottles. But what kind of bottles to use? It varies from country to country. These days at Heinz, there are 17 varieties of bottle and bottle size. The most popular is the newfangled plastic squeezy. But in countries like Germany, a more sober, traditional view prevails. There, the original glass bottle remains the ketchup container of choice. Only 8 hours after the tomato paste arrives at the factory, the finished ketchup leaves. Every day, almost 1 million bottles are shipped out to customers in Europe and Asia. But don't the